Hey guys, this is Ulrich from Nostalgic Mathematics. Today we will try to compute a ratio made up with square roots of big numbers without a calculator. I'm going to show you in this video how to get away with a simple trick. It has to do with some multiplication patterns. If you are new here, do not forget to subscribe. Let's imagine you have to figure out the answer of this multiplication quickly. I'm going to show you how to do this. First, let's start by 11 by 11. We know that the answer is 1, 2, 1. But actually what you do is like, you have two ones here. So you write 1, 2, and you apply a kind of symmetry based on the number 2, so that you have 1 on the other side. If you do the same with 3 times 1, you have 3 times 1 here. So you write 1, 2, 3, and then symmetry, and then 2 and 1. So it's like a mirror number. You do the same with 4 ones. So you have 1, 2, 3, 4, and then symmetry, 3, 2, 1, and you have the mirror number. 5 times, which was our initial question. So you have 1, 2, 3, 4, 5, and then symmetry or mirror. It depends on how you see it. So you have 3, 4, 3, 2, 1, and that's okay. But what if there is a gap? Like here, because between 2, 1, there is a 0. Actually, there is no gap here, but there's a gap here. I'm going to show you how to do this. Start by 1, 0, 1, multiply by itself. So let's ignore the gap. So you act like you have 11 by 11. You write 1, 2, 1, and then you fill the gaps with the same number of 0. For instance, if you have this one, you act like there's no 0. So you write, like here, 1, 2, 3, 2, 1, and then you fill the gaps with the 0. That's okay? We do the same with a gap of 2 zeros now. You do the same. You do like there is no zeros, so you perform like 11 by 11, it is 1, 2, 1, and then you fill the gaps with the same numbers of 0. This one will give you this because you do 1, 2, 3, mirror, 2, 1, and then you fill the gaps with the 0. That's how we do these multiplications quickly. But why does it work? First of all, let's notice that, let's take this number for instance. It is the sum of a power of 10. When you pick up this one, you can write it like this. So actually, these are power of 10 cubed. Here, it is power of 10. So to prove it quickly, we may focus on d square. 1 plus x squared plus dot 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 plus x raised to the power m squared for m greater than 1. Actually, the outcome is this. Okay, let's take a breath here. It is like what we did here. So you have 1, 2, 3, up to m plus 1. Actually, you have m plus 1 terms here because 1 is x raised to the power 0. You do like here, and once you reach m plus 1, you do the symmetry. You do m minus 1, and so on until 2 and 1. It looks like the trick that we have here. But to prove it, you just have to do polynomials multiplication. Let's focus on this term. Actually, we are multiplying this polynomial by himself. So we want to figure out how we can have this exponent m plus k. So we start by xm, x raised to the power m, and x to the power k, because we can't go past the exponent m. So we have m and k, and then m minus 1 and k plus 1. We can go the other sense, like m plus 1, because the greater exponent here is m. That's what you have here. And then do the same until you reach k again. We finish with m. You can go past, because if you have k minus 1, you will have m plus 1. It is not allowed. So it is written as this sigma, but between k and m, you have m plus 1 minus k numbers. So that's right. This is the coefficient of this little polynomial. So we do for this case, it is very simple here because k is less than m. So you start by k and 0, k minus 1 and 1, 0 and k. Actually, this is that sum, and you have k plus 1 terms. So the coefficient is correct. So this result is the application of this other result with x being a power of 10 for m less or equal to 8. So actually, when c equals 1, you have this case, there is no gap. And this is how the numbers is written in base 10, 1, 2, until n plus 1, and then you do the mirror. So when you pick up a C greater than 1, you have the case with gaps that we have seen here, and that explains it. Okay, let's finish it off. We want to simplify this ratio. Actually, we will apply the multiplication patterns we have seen previously. So this number we write as this because we have 4 times 1 and a gap of 1, 0. So we apply what you have seen. And then we do the same for this other number. And then we have 2 times 1 and a gap of 3 zeros. It will write as this. So all these numbers are perfect square. And then applying the square roots, we have this and this. So the original ratio becomes another ratio. That's good because this number is a special type of palindrome. We know how to use it. So we will write as this. We use the first 2 1. We can multiply it by this power of 10 with 4 zeros. And then we have the same number, 101. And then it factors as this. So we can deduce this ratio, which is 101. So the answer is 101. Thank you for your attention. Again, do not forget to subscribe, like, share, and post your comments.